Hello, this is a note about using the program qtVlm to study electronic navigational charts. In other words, we want to look at some details of the charts and how we can use a couple special features of the program to study them. And it came about in our new course on electronic charting, where we have a section here. We're in what we call the Cape George Rock School, where there's all these rocks along here, and we're comparing what these rocks say with what we might learn from viewing them on the standard paper chart, the RNCs. And most of these agree very well. For example, let me look at number 11 here. Number 11. Okay, so that's this rock right here, and I right-click it and say vector chart information. And what do I learn? It's a rock that covers or uncovers, and it has a sounding of -6. Now, a negative sounding means that's a drying height, because the baseline, the reference is the zero tide, and the depths go positive down, so going up is a negative. So this is a drying height of 6 feet for rock 11. And then if we come back here and look at rock 11, okay, so it says 5 feet. That's pretty close. But anyway, see, underline with the brackets, and underline is a 5. Underline means that's a drying height. And that's that. So it agrees. It's a minus. This says 6. That says 5. And that discrepancy comes about because the ENC charts are native units meters, and so we're taking a native meter chart, which then I said display in feet, so that I could compare with this. And that's a rounding error. Okay, so that's not important. They agree. And then I can just say here, vector. I want the vectors on. I can just say that we've checked all these, and they agree. All of them agree. Now, up at the north here, though, we find a couple interesting things, one of which led to a little research here, which I want to talk about to illustrate these tools. First of all, there's 3 rocks, number 16, number 15, that's this one, and then somewhere down here there was another one, number 12. So that rock, these simply don't show up on the RNC. So that's something we want to investigate. That's a little bit harder problem than the one we're working on now. So what we're working on now is rocks number 13 and 14. You see 13 and 14. And if I right-click these rocks, like this guy here, I go in here and I get a cursor pick of him, vector chart elements. It's a rock, covers and uncovers, it says, and it doesn't say anything about any soundings, but it says it covers and uncovers. Now, this other rock says exactly the same thing, number 14 here. Vector chart elements, same exact description, and that's wrong. That's totally wrong. Now, and I want to show that. And then, and so this leads us to one of my big concerns is we don't want the ENC charts, the so-called new ENC charts that are going to replace all the RNC charts, replace all the paper charts. We don't want them going backwards. They, in principle, can contain much more information, so they should include more information, not less. But let's look further into this to see what the point is. Let me go look at the raster version of those 2 rocks. And those 2 rocks are here. Notice that. That's 13 and 14. These little rocks are actually islets. Islets. They're not rocks at all. Well, okay, it's a rock, but it's an island. It's whatever. But this has then outside, this is kind of like big unit to look at. But you see now in parenthesis out here, here's parenthesis and an underlined 5. That's a drying height. Here is in parenthesis 4 without underline. That means that's its elevation above mean high water. That's its height above mean high water. And that's 4 feet above mean high water. This one's 3 feet above mean high water. So that's what these rocks should show. The parenthesis here is just so they don't get mixed up with a sounding. See, this one with a minus, that would not necessarily get mixed up with a sounding, but this one would get mixed up with a sounding, so it's a parenthesis. So whenever you see, quote, a sounding with parenthesis on it, that's not a sounding. That's an elevation above mean high water for some nearby rock. And if the scale of the rock is such that it's just, you can't show this detail of a little island like that, then it just puts an asterisk. And so that's the deal. So now, so the question is, before we raise this and call NOAA and say we got a charting error, we've got to prove that this is really the case. It could be that this is the chart that's wrong. And that's where we can get into the tools that we've got with this program. So what I want to do is a couple things. First of all, I want to look at this in Google Earth, because if these rocks are 3 or 4 feet above high water, they should be visible in Google Earth. And so what I'm doing here, and here's the trick. So first of all, I go in and just put marks here. Like I can right-click, new mark, and make a mark and give it a name or something. Right? I don't want that right now, but I'm just showing that's how easy that is. Delete, yes. Okay, so I put marks here. I put 1 mark on each rock, and then I want to, these tide heights matter in this case, so I want to mark on this chart the line that marks mean high water. So if you cursor pick this green area, let me do that, cursor pick that, vector chart elements, what that's telling us is a depth area. And the depth area goes from 0, that's the 0 right here, this line, this blue, where the blue meets the green, that's when tide equals 0, that's where the water meets the land. This is the datum of the sounding. That's the sounding datum, 0 feet. Now, this line back here is where the water meets the land when the tide is equal to mean high water. That's back here, mean high water line. And the way that these these ENC, the way the American, U.S. ENC tell us this mean high water is they tell us the height of this contour here as negative number, -9 feet. So the water is up 9 feet north of a sounding, right, above a sounding. So that's the drying height sort of the water. That is the height datum for this chart. That's mean high water. So that's 0 tide, that's mean high water. On every U.S. chart, that's what the green foreshore is defining. So that all makes sense. Not makes sense. That's the way it is. And furthermore, U.S. does this very well. Other nations don't do as good a job with that, but I'll let that subject go for now. U.S. charts are best at how to find mean high water. You want to be in U.S. waters if you only have ENC charts. Okay, so so what are the tricks? There's 2 tricks we want to do. First of all, I want to take these marks. I want to do a Google Earth view of this exact screen. That's easy to do. I'm just going to hold down 2 keys. I'm on a Mac, and it's going to be Command and Option. I'm going to hit the G key, and it's going to load that picture into Google Earth. Load that view into Google Earth automatically. But I want to do more than that. I want to overlay these marks here. So I make these marks like this, and these are things you can do to play around with looking at the beach or looking at other things on Google Earth compared to a chart, and do it digitally. So I got these laid here. So now I made the marks. I do Command M, and then I find these marks here, and it's this one, 0 tide, that's one of them. That's one of them. North end of that's one of them. That's 2. And these are the 2 rocks. No, not that one. It's 13 and 14. It's that. So those are the marks I want. And then you just say export as a GPX, give it a name. And I've already done it here, rocks and beach GPX, okay? Cancel. So you export that as a GPX file, and you've got those rocks. Okay, now let's go push these keys and see what happens. Shift Command G, and that should open up. There it does it. Okay. It did it just fine. Oh, okay. Now my Google Earth has somehow got into some strange mode that whenever I move something, it tries to rotate it. or tilt it or do something. To get rid of that tilt, you got to hold the shift key and rotate, rotate up, and then hit the N key or push this to get north. Okay. You see that? That's a function you can shut off, and I'm not going to stop and try to figure out where to do that now. But let's go back to this area, something like this, and then I'm going to try to get it flat. Okay, I got it flat. Now go north. Now maybe I can just use the keys to go down. Oh yeah, that's better. All right, so then once you've got this picture here, these didn't come in here. Then what you have to do is you have to go to your Finder, and then you go to where I saved those. Where did I save them? In the downloads? Yeah, you go to your downloads, just grab that file, the GPX file, and drop it on here. Just drop it on here, and it'll draw those lines. It'll put the marks there. After you put the marks there, then you can go to this tool, this kind of tool up here, and draw a line like that. Cancel, clear. I don't need it. And that's what I did. So I dropped those marks all here. So look, the rocks are where they're supposed to be, sure enough, right here. 13 and 14, and they're visible. And now we want to look at what the tide level is. And then, so here is the water level, and that looks like it pretty much matches. One thing of interest that you can do, let me go back to the program. If you go back here and click this line, this border line right here, and you do a vector chart, do that, coastline, and you see this coastline has a category, steep coastline. Now, some will just say coastline, period, no category. And so that's less defined. When it says steep coastline, then that means chances are mean high water ends right there. We've got another really nice example of how you can do this same sort of exercise I'm doing here, you can do to study that effect. About where is a coastline expected to be sharp, or is it going to blend up? Now, granted, that may be of more interest to kayakers, but you could be in a small boat and needing to go ashore at some time under some emergency and may want to know how to do that. But, okay, so here's our situation. First of all, those rocks are indeed there. I see them on Google Earth, and they're in the right spot and so forth. And then they're also here in about the right spot. You see, if I look at this, if I look at number 13, it's basically right on the zero tide level, and this one's a little bit off of it. So that all makes sense like that. Then I can go in here and measure this distance. You can use your tool here and, click this and say that this area here, the foreshore, is going to be about 140 or, 137 feet long. And the tide at the moment, see, zero tide, this water would be right here. High tide, mean high water be up here. So this tide is right here. That's equal to about 88 feet or something. In other words, there's 88 feet of water encroached in on there. And from that, we can actually figure the tide height at the moment of this picture was taken. And I've got that here. So here's the way I did that, and you can just play with this if that's of interest. This is the full 137 feet of the foreshore, the green foreshore. The tide, this is 9 feet, the mean high water, and that's 0. And at 86 feet, this is where the tide is here. And it happens to be, the tide, in this picture, the tide's about 5.6 feet. And you have this ratio here that you can figure that. Then we can go and look at the rock heights. In other words, how much rock are we seeing in this picture here? And I'm just following through with this analysis. So here's the mean high water of this number 14. The rock is 3 feet above mean high water. Rock 13, 4 feet above mean high water. But now we're at tide 5.6. Which is below mean high water by 3.4 feet. So this extension from here to here is how high that rock is out of the water. And this one's 7.6 feet. So this is, if I had a way to, this thing is trying to do 3 dimensions, but, it's just not going to make it at all. Let me go north here again and get rid of this. Okay, I think that's all I wanted to say. In other words, we have an honest charting error here. These are two real rocks. Their drying height, their elevation. It's not even drying height. They're not drying. These rocks are above mean high water. So it's not a drying height. The elevation of these rocks are known. Technically, it would be not so much the elevation, the height of the rocks. Elevation refers to contours on land and spot elevations. If I have a contour on a chart, an elevation contour or a spot elevation, those two heights are relative to mean sea level. This is now a real subtlety in charting, but those heights are relative to mean sea level. But the height of these rocks above, the way that's put on the chart, this is above mean high water. Okay, so that's where I'll end with that. It's illustrating, well, obviously some details about rocks, but more importantly, in a sense, a couple powerful tools you can play with qtVlm.